Okay, so I'm glad to introduce our first plenary talk. I want to introduce you with Peyman Milanfar. Peyman Milanfar was a professor at University of Santa Cruz for 15 years and is now distinguished scientist at Google and is leading the computational imaging team at Google. Of course, computational imaging changed photography, and he will explain us how computational photography and AI is revolutionizing the photography. So a warm welcome to Peyman. And, to you.
Thank you.
Thank you.
All right. Well, thank you very much for inviting me and for that warm welcome and introduction. It's my pleasure to be here. I hope to give you at least my point of view on how imaging is changing in the age of artificial intelligence. For those of you who are used to seeing me give very technical talks, this is not going to be a very technical talk. This is more an overview, it's kind of a summary of things that we've done, some personal observations, having been both in academia and in industry for the last 10 years. All right, so let's begin. I think we can all agree, it's not a controversial point, that smartphones changed the world. Not very long ago, just 15 years ago, it's not very long ago, really, we still relied on a bag of different devices to do things, for navigation, to play music, GPS, et cetera, et cetera. And today, we just need one. All of these things have been squeezed into one. And so in a very real way, smartphones changed, and as this article states, and then the smartphones changed us. And so I hope to convey this idea to you that I think another big change is happening, and we're right in the middle of it. In order to understand mobile photography and imaging, I think it's useful to look at the history a little bit. So let me give you a very coarse idea of the history. In the 1880s, the old school, if you like, this is an ad from 1880-something, 1884, I think. And I want to draw your attention to this little red box that says, "You press the button, we do the rest." Isn't that what we still say? I mean, it's been so many years, and it's still pretty much the same thing. The ethos really hasn't changed. From the 1930s to 1990s, photography was dominated by analog photography and, film. In the following 30 years, digital photography was king, both in terms of DSLRs and also in terms of point-and-shoot compact cameras. Almost all the pictures I have of my kids when they were born around that time are with compact point-and-shoots like the one on top. And then since 2010, we've kind of entered this age of computational imaging. But let me be a little bit more granular about the recent history. In the mid-1970s, the first digital camera prototype was invented, and somehow coincidentally alongside it was the first consumer Polaroid camera introduced to the market. In the 90s, in the early 90s, first consumer digital camera was introduced. At the time, they were super expensive. And shortly after that, 3 or 4 years after that, the CMOS process was introduced. But it wouldn't become practically useful for several years thereafter. Then in the 2000s, in the early 2000s, the first consumer camera phone was introduced. This picture that you see up there is the J phone. It was actually manufactured in Japan. And at the same time, photography, as I mentioned, was popular with digital SLRs and compact. So the camera on this thing was really not much to write home about, and it didn't really catch on. And then in 2010, something big happened. Or actually, some big things happened, more than one thing. And I want to show you kind of little by little what I think happened in 2010. So if you didn't believe my assertion before, take a look at this picture. One from 2005, the other one from 2013. And I want to draw your attention to this lonely person in the corner with a flip phone taking a photo. Nobody else was doing it. And then in 2013, absolutely everyone is doing it. So what happened? Well, a few things. Before we go there, let me give proper due to Apple. In 2007, they introduced the iPhone, obviously, and they really did reinvent the mobile phone at the time. But the story was all about the display and the user interface, going from physical keys to basically the whole screen being an affordance for the user. They didn't really reinvent the camera at the same time. Again, the reason is that there was competition at the time. If you watch the 90-minute presentation that Steve Jobs gave at the time, there was literally one sentence about the mobile photography there. He said, on the back, the biggest thing of note is we've got a 2-megapixel camera built in. That's it. He moved on. Okay, but then obviously, some things that you're all familiar with began to happen. For instance, around 2010, you begin to see that we exceeded the 1 billion transistor count on the semiconductor devices that were being built. Multi-core processors began to make an appearance on mobile devices. And then obviously the historical prices of computer memory and storage began to reach unprecedented low levels. But was that enough? Turns out not quite. There were a few other things happening. Communication speed was speeding up a lot. If you look at 1G, 2G, and so on, consider the size, in today's world, the average size of an image that's being shared in social media is about 2 megabytes. 2 megapixels. And in 2000, the average time to transmit it was about 30 seconds. By 2010, that had been cut down to half a second. And now, of course, it's well below a tenth of a second, but that's a whole other story. And at the same time, around 2010, 300 DPI displays were introduced, which meant that the resolution of the device in your hands matched the resolution of the computer screen. So what does that mean? It means you were able to take a photo, enjoy it on your screen, and send it to a friend, all within the span of a second or two. And so unsurprisingly, Instagram was introduced in 2010. They timed it really well. Somebody was paying attention. And so the rest is history to some degree. Okay, so as I mentioned, I hope this point was driven home that some big things happened in 2010. And the point of sort of the rest of this talk is that some big thing is happening now. And this is the age of artificial intelligence that's going to change our relationship, not just with the mobile phone itself, but also with mobile photography in particular. All right. Now, you might ask, why am I going to speak about mobile phones in particular? After all, DSLRs are much more powerful for photography. The DSLR on the right captures 300 times more light. Mobile phones have tiny sensors, typically 10 bits per pixel, limited zoom, fixed aperture. And DSLRs have large sensors, larger bit depth, wide zoom range, adjustable aperture. The big difference is compute power. We put more and more compute power on the mobile device, and somehow that's not kept up on the DSLR side. And of course, the low cost. This reminds me of a saying that a few years ago was popular, which is that the best camera is the one that you have with you. Right? And you're not going to have the DSLR with you all the time. So the idea is that the mobile phone was going to take over. And because of these limitations, actually that is a strength for impact for artificial intelligence, AI techniques, machine learning techniques. So that's kind of my motivation for sticking to mobile imaging for the rest of this talk. In fact, we have made some big progress over the last few years. I think our friends at DxO know this as well. Not very long ago, mobile phones were not even competitive with micro Four Thirds cameras. But now, I think with proper processing, we can get quality and resolution that is actually at least as good, if not better, than micro Four Thirds cameras. But still not, obviously, the larger format cameras. Now, you might think, okay, this is great. We have imaging, and we have a bunch of progress in machine learning. But is there demand for this? Well, to some degree, it's a chicken and egg question. It's a question of what you bring to the market. but at least as of this survey, which was done in late 2024, 1 in 4 Samsung Galaxy buyers said AI was a key reason they chose their phone. So, that's something. It's something to build for. But also, much more broadly, this is not the only survey. There have been many others. Which AI features are US customers keen to use on their phones? And after, like a voice assistant and so on, the very next one is photo and video tools. So there really is a demand for this because people want to capture good photos. They don't want to put a ton of energy into it. And if you can do really sophisticated things to produce very good results for them, they welcome it. Okay, so let me give you my personal experience with this. And this is, with my wife's permission, this is a story of how she puts together our holiday cards. My wife is very artistic. She loves to spend a ton of time going through hundreds, if not thousands, of photos that we take over the course of a year, select the best ones, put together kind of a story, bring it in, and after many, many days of work, produce a singular, memorable, high-quality creation to share with our friends once a year. And over the course of the last several years, one thing I've observed is that the time it takes her to do this has shrunk. And that's because of the tools that we've been able to provide. But let me give you a bigger picture of all of this. It's a very long way, if you really think about it, from the raw material of photography to a creation that you want to share with people. It's not always instantaneous. In fact, it's not often instantaneous. So you've got the intention step. That's the point at which you decide, okay, I'm going to pull my phone out of my pocket and take a picture. Then you've got the actual capture experience where you set it up and you touch the screen and you make sure it's in focus and the lighting is good and all that stuff and the kid's not moving and so on. And then you've got the curation and organization. You've got, as I showed you, hundreds, maybe thousands of photos you might want to look through. And then you've got post-processing. You might want to make some changes and improvements and so on. And then finally, you've got the step of publishing or sharing. With all of these steps in place, there are many pieces along the way where machine learning, AI can help. So I want to give you some examples of how we've contributed to these various steps. Obviously, the first one is to take a great shot. That's the fundamentals, right? That's the bread and butter step. So second one, you've captured a bunch of shots. You want to find the right shot. That's the curation step. We want to be able to do that more automatically. Then there's the enhancements I talked about, and then there's creative tools. And I'm going to give you examples of all of these things one step after another, things that we've done. Okay, so take a great shot. First of all, I think it's important to point out that if you look at this, this is the traditional single-frame camera pipeline. It is more or less no longer in use in almost any mobile phone. But it's fair to say that there's already a bunch of steps in this that you could immediately use machine learning models, and most have. For example, the noise reduction or the digital upscaling, these can all be done with machine learning models. To some degree, basically, whatever generation of mobile device that you have, going back 5 years, probably has some kind of machine learning model in it. Okay, but more recently, in part spurred by work that we did at Google, with the early versions of the pixel camera pipeline, is the multi-frame capture pipeline. And the multi-frame pipeline is somewhat different in the sense that one picture is not just one picture, it's an aggregate of multiple pictures shot within a span of time and then mixed together. So there are various manifestations of this in the camera pipeline for Pixel devices. I'm going to specifically talk about super res zoom, which is something that my team has contributed to a lot. But it's fair to say that the general principles that I'm describing are applicable to most other pipelines as well, whether it's for zoom or not zoom. Okay, so zoom is inherently disadvantaged on a mobile device, in part because the devices are thin. The so-called Z height basically limits how much space you have between the lens and the sensor. Whereas with traditional cameras, you have a lot of space in which you can move. So basically, if you look at a mobile device, the best thing that we can do, the only thing that we can do, is to use this tiny space and folded optics in order to basically bend the light multiple times and then hit it against the sensor. So that's what we can do. And because of this, typically, but not always, optical zoom in mobile devices is limited to between 5 and 10x. I mean, some manufacturers, some OEMs have gone up to 10x and then actually changed their mind and gone back to 5x because it's more stable and more reasonable. But so let's say it's limited to 5x. Now, if you look at this picture here, this sequence of pictures here, I want you to guess how much zoom do you think this is? It's way more than 5x, I will tell you that. This turns out it's only 30x. And you see how big it is. I mean, actually, the first shot is a 0.5x, so it's an ultra wide, and then it goes all the way to 30x. So that's a really long distance. And if I were to just, for example, take this little crop, this little red dot that I put in there, that little region there is only roughly about 50 by 50 pixels. So if you want to build zoom that goes all the way back to a small thing all the way in the back, that small, you've got to do all the optical stuff that you can as well as you can, and then you have to do digital upscaling by quite a lot, right? So it's not just one thing or another. All right, so how does this pipeline work, and where can you bring in machine learning? I've color-coded this a little bit to tell you roughly how difficult it is to put machine learning models here. Alignment is, I colored it black here because it's generally very well established core technology, and you don't necessarily need machine learning to do alignment. You can if you want to, but it's not necessarily all that beneficial. The merge part is red because remember what you're doing is you're taking as many as 2 to 10 frames and you're squeezing them all out into one frame. So you can build a machine learning model for that. It's not the easiest thing to do. Then you've got the enhancement step, which is tone and color correction, noise reduction, and so on. And then if you want to upscale, you then crop this, and then you put it through an upscaler. And this is what, unfortunately, is called single frame super resolution. It makes it a little confusing with this multi-frame super resolution that I mentioned here. And the multi-frame super resolution by itself, by the way, it brings actually some additional resolution beyond the optical limits of the camera, depending on what the sampling rate is, so on and so forth. So you're going to get some benefits up here, and then you're going to get some upscaling up here that has to be done really, really well. Now, if for those of you who are in the business of solving inverse problems, you realize there's one step here that's skipped, I haven't mentioned, and that is this whole process of imaging includes in it the lens point spread function. And I haven't talked about that, but you can do that too. You can actually have a deblurring step that removes the lens point spread function as well. And as I said, this approach is very general. I mean, if you just ignore the upscaling step, then this approach can be applied to any of the cameras, whether it's main, tele, wide, or others. So just want to give you an example. This is a photo that a colleague of mine, Michael Specht at Google, took. This is about 14x overall zoom, shot on a Pixel 9 Pro, which is the last model that we released last year. As you can imagine, you can't get too close to this puffin, so this is really the only way you're going to get this picture. He was in Iceland and he took this beautiful photograph. The level of detail and kind of fine level grain that you can see here it makes it look like it was just not zoomed in at all to some degree. All right, now let me talk more about single frame upscaling, which is something that I think a lot of you know I've worked on for many, many years. The idea here is to produce higher resolution, sharper, and cleaner images. So I'm showing you an example of, this is not a simulation, this is, this is an input from a crop from an image, and on the right-hand side is the upscaled version by 3x. This is the kind of technology that we are using in the Pixel cameras to do upscaling. Here's another example. This is 4x. And the important thing here is to be able to preserve not just the color and the tone and so on and so forth, but bring out realistic details that are anchored in what was already in the scene as opposed to just kind of making things up. Furthermore, the multi-frame approach that I just mentioned is equally applicable to challenging imaging situations where low light is the prevalent scenario. Now, with low light, things are a little more complicated because the bursts have to be longer, the exposure time has to be longer, the likelihood of you getting motion blur is higher. But this, basically, the night sight pipeline in Pixel does a similar thing, but it trades off the total exposure length with the individual frames somewhat differently. We purposefully underexpose so that we don't lose the highlights, and then we mix things together with a bunch of machine learning models as well. All right, so I talked about capturing the photo. Now let me say a few words about finding the right shot. So if you look back, if you're old enough, you remember the days when a box of film, a roll of film with 12 exposures was pretty expensive. You would buy it and you would very, very carefully set up your shots, and you would take the 12 exposures, and boy, you worked so hard, and you would get rewarded with 6 really nice shots. Then we went to 36 exposure rolls, and the price of the roll was less. You were a little less careful, but you still managed to get, 6 excellent shots. Now you have memory. You have thousands of exposures, and you're just kind of shooting all over the place, and you still only have 6 awesome shots, right? And so the problem, if you do the capture side right, there's still a problem of curation that you have to solve. And so in 2018, with my colleague Hossein Talebi, we wrote this paper called Neural Image Assessment, and the idea here was to try to learn from human experience. And so the data for this model, it's a deep neural network. Let me tell you what it does, and then I'll tell you how we got the data. Basically, an image goes in, and out comes a histogram of scores. A poor score is a 1, an excellent score is a 10, and we can say, what axis this is along. Is it good quality, or is it aesthetics, and so on and so forth. But the way the data for this was collected was you have a group of sort of semi-pro photographers, and each of them contributes some dozens or hundreds of images to a competition, if you like. And then everybody rates everybody else's photographs on a scale of 1 to 10. And that's your data. And we trained a model on it, and this is what it does. So this was several years ago now. It's almost 6 or 7 years ago. Let me show you kind of what you can do. Let's say you can tune NEMA, this model, for aesthetics. It says, I have all these photos, which of them are the more aesthetically pleasing? Or you can tune it for technical quality. That tells you, is it noisy, is it blurry, is the subject in focus, et cetera, et cetera. And the other thing you can do with this, you have to be super careful about it though, is you can use these kinds of perceptual losses, these kinds of scores as perceptual losses. So this is an example that we did from this paper, Learned Perceptual Image Enhancement. The image on the left was given. The image in the middle was edited by a human expert for tone and color and so on and so forth. And the image on the right was edited with a neural network which has NEMA in it as a perceptual loss. And the goal, of course, was to match the human expert. So these are the kinds of things you can do with it. All right, now let me move on to AI enhancement and editing. So we've done a number of things in this space. Not everything that I'm describing here is specifically my team. There's several different teams working on these. But the idea behind Magic Eraser, which by the way is the most popular, one of the most popular features right now on Pixel, is the bottom line is that you want to focus on capturing a scene, a moment, without being distracted by the little things that can ruin an otherwise perfect shot. How many times have you tried to take a photo of something and then you said, no, wait, there's a guy behind you, or, don't have to worry about that. Just take the shot and then you can remove the distractions thereafter. As you can see, there's a bunch of different things that you have to do here. You have to it's not just about segmenting and removing objects and making those suggestions automatically to the user, but it's also about intelligently reconstructing the background so that those holes that you've now created by removing the object are seamlessly filled. This is a difficult task, and this is something that we've been working on for many years. We can do it basically at interactive rates now, which is very nice. Another one is best take. So remember I mentioned the shots that we produce now are from a burst. It is often the case that if you take a burst of photos and you're given one photo, not everybody in the photo might be having the right expression, especially when kids are concerned. So what this allows you to do is when you have that burst of photos of the same moment, you typically have options to get the best aggregate shot. And in fact, if you don't have exactly the expression you want, you have many other images of people that you could use, of the same people that you could use, if you have that intelligence built in. So this is a very handy thing. I've used it many times myself. So the last two things that I mentioned were not directly things that my team has been doing, but the next two things are work that have been principally directed by my team. The first one is photo on blur. I mean, it's sort of self-explanatory. Who hasn't got a problem with blurry photos? It doesn't matter how good your capture is. It doesn't matter how good your camera is. It doesn't matter how good the photographer is. You're always going to have blurry photos. And furthermore, it's not just about the blurry photos that you have now or this year. It's about all the photos you have stored in Google Photos or Apple Photos or wherever that you store. You go back, you will find blurry photos. And blur itself is quite complicated. You've got lens, you've got out of focus blur, you've got camera and object motion, you've got one or the other, so it's very complicated. And so what we did here is we set out this problem of solving the following problem. Take an image that you would otherwise decide, oh, this is too blurry and I'm going to delete it, and bring it back to the point where it's useful. Sometimes a photo may be blurry, but it's so precious that you don't want to delete it. So you'll hold on to that blurry photo. That's how I feel about this photo of my daughter here. She was, I think, 3 years old. I love this photo, but it was always blurry. And in my academic work, by the way, I have worked on deblurring for a decade and a half. And it's always one of the hardest problems to do because it's not just about removing the blur, it's also about removing noise. And it's very unstable. So, anyway, surprisingly common problem. It's been very, very popular. It was launched on Pixel 7 in Google Photos. It's become one of the most popular corrective editing features. It's available on all Android and iOS devices as long as you have Photos, Google Photos. And it handles complex motion blur, out of focus blur, and noise simultaneously. So here's a few examples. Again, these are all real photos from my own experience and my colleagues' experience. So in this particular case, it's an autofocus failure. In this case, this was an old photograph. The kids never stay still. You got to take a picture when you can. So now I'm really happy with this photo. This is a selfie or some kind of candid that was taken of some celebrities. Almost always candids and selfies turn out to be a little bit blurry, so we can fix those. And this is one of my own family, a good maybe 15 years ago from an old photo, an old camera. And I remember this camera was a point-and-shoot camera, so it didn't have a selfie mode. So I actually had to turn the camera and take it. I had no idea what it was going to look like, and it turned out blurry. And finally, this one, this is my kid when she was just born. I think she was like 3 days old here. And 20 years later, I'm able to get a much, much clearer version of it. Okay, and I'll have to show a DxO chart while I'm here, so we can deblur that too. Okay, so that was a couple of years ago. This past year, we launched another feature called Zoom Enhance. So the idea here was that this is a post-capture feature. So the upscaling that we do in camera is basically using the camera pipeline, then it's cropping and upscaling. This brings a more powerful model. This is a diffusion model now that runs on device, but it runs on your already captured photos. So it's not running in the camera pipeline, but post-capture. This was launched in the Pixel 8 and 9, and you can crop and zoom any photo, and perceptually, depending on the scene and the various conditions, it can get you roughly sort of 2, 3, 4, maybe optical zoom equivalent. So it's kind of like a virtual telephoto lens, if you like. This, as I said, this is a generative model. This is a diffusion model. Runs on our Pixel Tensor G3. This was a really challenging project. Bringing diffusion models to run in a reasonable amount of time on device is really, really difficult, and to get them to have the right quality. So this runs, as you saw in the previous slide, this is, the animation is real time. So it takes about, I don't know, 7 or 8 seconds, sometimes 10 seconds to do this kind of crop and zoom. And then we have, besides this, we have specific face and text models to get better quality and authenticity. So what are some uses? Here are a few. For instance, you can isolate a subject. So you can look here, that's little red zone here is the crop. So this is a very tiny crop that we're able to enhance and make it look like a high quality, high resolution image. This is another one here. The camera was actually at the maximum zoom. So it was at 30x. When we took the picture on the left, it's taken at 30x. We push the camera to its maximum. You can't go any further, but you want to get a little bit better crop of the squirrel, and so that's what we can do. The right-hand side is the outcome. I've had this problem many times. You cannot get close to Mona Lisa. You just can't. So you do the best you can. You take the zoom that you can get away with, and then you try to get the best version of Mona Lisa out. Now, you might argue very reasonably, is this exactly what was painted? Of course not. These are generative models, but does it look better? I think you would agree it does. And as I mentioned, we use face-specific single-frame upscaling, and so these are just a few example results, and we use text-specific single-frame upscaling as well, and a couple of examples of that as well. Now, having these technology pieces in place, we can also compound them. So let me go back to a really old photo. This is a portrait of Margaret Hamilton, the pioneering computer scientist from 1989. It's a really low resolution photo. I think it's like a couple of hundred pixels on each side. And so we ran unblur on it. As I said, it fixes the blur and the noise and the compression artifacts. But it's still, that was still only a couple of hundred pixels by side. And then we upscaled it to the one on the right. And I think this is something you can actually put on a website. All right, creation tools. Let me say a couple of things about creation tools. I won't go too deep into the technology here. Now here we're going away from actually doing image processing to more kind of storytelling. Here the idea is you want to move an object, you want to change the sky, you want to change the framing, all things that maybe are kind of at the border of whether you call them photography anymore. These are really complex editing functions that are made easy. The other one is a feature I really like called Add Me, and that is make it easier to take group pictures when you don't have somebody to take a picture of you. So what's happening here in this animation is that one person takes the picture, gets out of the shot, the other person sits, and then you take the picture. And so everybody's in the shot that comes out. And with this, you can play fun games like make twins of your colleagues and their children, and so on. So as I said, this is going a little bit out there now in terms of away from kind of core photography and doing more creative things. All right, so what are the challenges ahead? I think, in whatever the next 10 or 15 minutes, I'm going to try to give you a sense of what some of the challenges are. I've hinted at them. So first of all, device limitations. As you can well appreciate, running complex AI models is compute, memory, and power intensive. And the question is, can devices keep up with these things? I would say right now we're really at the edge of pushing the devices with power and energy and thermals and so on and so forth, everything in order to allow us to do a lot of these AI functions. So will this kind of trend of being able to get efficiency and more memory and more efficiency, will it continue? Hard to say. The other question that's on everybody's mind is edge versus server. Running models on the device has a lot of advantages. If you can get it to work on device with relatively low latency and interactiveness, that's very attractive to the user, partly because it gives privacy. It allows for you to build for privacy. There is no inference cost to the manufacturer because everything is done on device. They don't have to pay for cloud inference. And no connectivity is needed, right? You can just do things on your device. On the other hand, in the cloud, you can do many more demanding tasks. You have higher compute power. It's fully scalable. You can send it to all your devices. It's not dependent on how strong your edge device is. But it does have an inference cost for the manufacturer, and you need connectivity. So, which is the right thing to do? It really very much depends on the particular use case. And I think it's something that's still an open question. And of course, if you have edge versus server, there's always the hybrid model. Like, maybe you do a little here and you do a little there. Those are all open questions. The next one is user customization. I've said a number of times that already in this talk that automation can do a lot of things for you. But some users may prefer to do their own editing and to have their own sense of what's aesthetically pleasing. For me, if I look at these two photographs, I like the one on the left. I think it's subtle. I think it's beautiful. It's kind of how I remember it, maybe. But the thing on the right, in some degree, is much more compelling. It's richer colors. It's much more dramatic. It might play much better on Instagram. Who knows? But if I just gave you one option, maybe that isn't enough. I want to be able to customize for you and what it is that you're trying to do. If you're trying to send the picture to your grandmother, that's a different customization than if you're trying to share it in Instagram. And then bias is a super important topic. Obviously, any AI algorithms inherit biases from the training data, potentially leading to inaccurate and unfair results. One very canonical example of that is skin tone. Here's an example of just a variety of different skin tones that cameras are built for, that should be built for, I should say, but not always successfully built for. And what we need to strive to do is to build cameras that can capture authentically all kinds of different skin tone. At Google in particular, we work with something called the Monk skin tone scale, and we try to make sure that our cameras are aware of the skin tones that they're capturing, and they adapt the auto-white balance and other factors to capture them right. But of course, as you can imagine, when you have a black box that's doing something, that's much, much harder to do than if you had tuning that was done much more specifically. And then finally, authenticity, I think, is a really, really important question. The quality of the results can become better and better and better as you have more data and more sophisticated models. Maybe not necessarily larger, but more sophisticated models. In fact, I would go as far as saying that you may reach a point where it may become impossible to take a poor quality photo on your mobile device. You just point and shoot it, and it just does an amazing job every single time. But then you have to ask yourself the question, is this an authentic photo of the scene that I was observing? And that is an ongoing challenge. Let me make a kind of temporal comparison to the concerns that we have. 7, 8, 10 years ago, with on-device models, we worried about latency versus quality. If you have a more sophisticated algorithm that gives you better results, then it might be slower. So that's what we worried about. Then a few years ago, we started building these smallish models, and then the model size was an issue. How many of these small models are you going to have? How much memory are they going to take? There's going to be communication between the models and the abstraction layers, et cetera, et cetera. Now you have a many-way trade-off that you have to do. There's latency, quality, model size, and authenticity. And I would say, generally speaking, this area is still in its infancy. And I think you can see that in not just in photography, but in a lot of areas of AI. So with that, let me put you through a quiz, if you don't mind. Kind of getting close to the end of my talk. I'm going to show you a couple of images like this, and I'll show you another one. And I want you to think about either of these images, whether it's captured with sort of minimal processing, if it's heavily AI edited, or if it's generated from scratch. So in your mind, think about which one of these three possibilities is more likely for each of these two images, okay? So here's one pair. Here's the second pair, same question, captured, AI edited, or generated from scratch. And I'm going to show you all four. Okay? Everybody have their guesses? Okay, so I'll tell you this. All four are generated. Nothing was captured here. In fact, the two here and the two here were generated with a prompt that says, show me an image that looks like it was generated, and a corresponding image that looks like it was processed. This is how good we can get now. So, of course, with this power comes with a great deal of responsibility. We have to be careful about how we use these tools and how we deploy them in the future of photography. But I think having said that, kind of a strange example, if you like, I think there's an opportunity to reinvent imaging. And I think that's the kind of crossroads we find ourselves in. What's a mobile device going to look like in 5 or 10 years? You know, will it be something like this thing from Tony Stark? Actually, this is almost 10 years old now, so it's kind of old. It's an old visualization. Maybe we should ask a science fiction writer or an anthropologist. This is interesting. This gentleman, David Gerald, wrote this in 1999, let's say 2000, so 25 years ago. He's a science fiction writer. He wrote, I call this device a personal information telecommunication agent, or PITA for short. The acronym also stands for pain in the ass, which it is equally likely to be because having all that connectivity is going to destroy what's left of everyone's privacy. Well, he was right. You know, look at 20 years ago. So maybe we should be going and talking to these science fiction writers or anthropologists to give us some idea of what the future might look like. And with that, let me show you a few possibilities of where things might be going. So certainly, being able to take photography beyond human vision, this is something that we can already sort of do. These are very low light photographs to the degree that if you were, for example, standing on the edge of this highway on the California coast, you really only would be able to see the lights and nothing else. And so this is a long exposure. I think this one is about 3-minute exposure on a mobile device. It's on a Pixel phone. Same thing with the one on the right. But not only that, we can even produce really compelling animations by making the capture even longer. And the same burst processing that I mentioned, if you change the anchor frame multiple times, will give you an animation beautiful like this. So this is just one example of kind of going beyond what you think you can do with a mobile device. But then there's bigger questions. You know, what's a camera? Is it physical or is it virtual? Suppose this camera was pointing at New York out the window, but it actually took this picture, right? Is that a camera or is that now a virtual camera? Who's a photographer anymore? Is it you or is it the AI agent looking over your shoulder? And where and what is the subject? You can make a subject be anything you want. Here's, you know, various landmarks from historical cities in Europe all jammed into one photo. And so with that, let me end with a joke told 40 years ago by Stephen Wright. He said, I got this new camera, it's very advanced, you don't even need it. Thank you very much.